Video on section 11.3 day 2, independent and dependent events. Please write down the essential question. How do I find the probability of independent and dependent events? Conditional probability often applies when data fall into categories. We're going to do this example in class. In many cases involving random selection, events are independent when there is replacement and dependent when there is not replacement. So if I go like this, independent when there's replacement, dependent, not replacement. Here's a reminder that a standard card deck contains 4 suits. So we have diamonds, hearts, clubs, and spades. That's what they mean by suits. Diamonds, hearts, clubs, spades. There are 13 diamonds, 13 hearts, 13 clubs, and 13 spades in a deck of cards. When they talk about face cards in word problems, they're referring to jacks, queens, and kings. 2 cards are drawn from a deck of 52. Determine whether the events are independent or dependent. Find the probability. A, what's the probability of selecting 2 hearts when the first card is replaced? So the first thing we have to pay attention to, replaced. I'm starting with 52 cards, and I'll still have 52 cards when I pick a second heart. Remember, you're picking 1 card at a time. Pick 1 card at a time. The probability of selecting a heart, as you can see right here, there's are all the hearts. There are 13 hearts in a deck. I pick out my card, I put it back. I still have a 13 out of 52 chance of getting a heart on my second pick. 13 times 13 is 169, and 52 times 52, 2764. That reduces to a probability of 1 over 16. This is an independent event because it's replaced. The second probability does not depend on the first probability because I put the card back before I did another pick. Let's go to B. Find the probability of selecting 2 hearts. Again, 1 at a time. Pick the cards 1 at a time when the first card is not replaced. Well, watch what happens. 52, if it's not replaced, then there's 51. There's 13 hearts, but if I take 1 out and I don't put it back, there's now 12. 13 times 12 is 156. And I reduce that's 1 over 17. This in B, this is a dependent event. The second probability depended on what happened in the first probability because the card was not replaced. Part C, what's the probability that a queen is drawn, is not replaced, and then a king is drawn? So again, we are picking 2 cards, but 1 at a time. The other thing I'm going to highlight is not replaced. There are 52 cards, goes down to 51. How many queens are there in a deck of cards? Well, if we scroll up and we look at our little picture here, how many queens? How many queens? There are 1, 2, 3, 4. There are 4 queens. So I have a 4 out of 52 chance of picking a queen. Then on my second pick, I only have a 3 out of 51 chance of, whoa, wait a minute, hold on. I have to fix something. Here's the deal. If I would have wanted to find the probability of getting a queen again, then that would have been a 3 out of 51. Oh, look what it's asking. It's not asking me that. It's saying, I want to know the probability of picking a queen. That's 4 out of 52. I pick a queen. I take that card out. I now have 51 cards to choose from, but I didn't take out a king. So what's the probability of getting a king? That's 4 out of 51. There's still 4 kings in the deck. 4 times 4 is 16, and 52 times 51 is 2652, and that reduces to 4 over 663. This is a dependent event. The second probability depended on the first probability. The total number of cards went from 52 to 51 because I picked my first pick and I did not put the card back. Why are they both 4 on top? Well, there are 4 queens in a deck. The card I took out on my first pick was a queen. So then on my second pick, there's still 4 kings to choose from. Example 3. A bag contains 10 beads. There are 2 black, 3 white, and 5 red. A bead is selected at random. Determine whether the events are independent or dependent. Find the indicated probability. All right, so we have 10. I want to write this down here because I know I'm going to have to scroll down and then I'll have this right in front of me. So there are 10 beads. We said there are 2 black, 3 white, and 5 red. Perfect. What's the probability of selecting a white bead, replacing it, and then selecting a red bead? Selecting them one at a time. Well, there are 10 beads. I replaced it before I picked the second bead, so there's still 10. How many of the 10 beads are white? I have a 3 out of 10 chance of picking a white bead, and I have a 5 out of 10 chance of picking a red bead. 3 times 5 is 15. 10 times 10 is 100. That reduces to 3 over 20. This is called an independent. I did not spell that correct. Let's try that again. Independent event, because the second probability did not depend on the first probability because we replaced the first bead we took out of the bag. B, what's the probability of selecting a white bead, not replacing it, and then selecting a red bead? There are 10 beads, but if I don't replace it, then there's only 9 to choose from. We already said that there are 3 white, and then how many red are there? There are 5. 3 times 5 is 15. 10 times 9 is 90. 15 over 90 reduces to 1 over 6. And notice I'm reducing these fractions. You should get in the habit of doing that too. Oh, this, by the way, is dependent event because the second probability depended on the first because we picked a white bead and we did not put it back in the bag. We're going to select 3 non-red beads. So 3 of them, one at a time, means I'm going to have 3 fractions. There are 10 without replacement. Started with 10 beads. Then that goes down to 9. And then that goes down to 8 because I'm not putting them back. 3 non-red. Well, 2 black, 3 white, that would be 5. 5 of them are not red. Well, that means, okay, I took out 1 that's not red, then I only have 4 to choose from, then I only have 3 to choose from. 5 times 4 times 3 is 60. 10 times 9 times 8 is 720. If I reduce that fraction, I get 1 over 12, and that is my probability. This is a dependent event. The 3/8, the 4/9, they're all dependent on the probability before it. Please read these video questions, do the work in your notes, pause the video, and then you can be done.